Hello, everyone. This is going to be our data analysis chapter. We have about 3 videos for this section, so it's kind of short and sweet, but we're going to look at a few things when it comes to analyzing data. The first thing we're going to talk about is evaluating misrepresentations of data, which, believe it or not, occurs more often than you probably would realize. Now, let me just show you an example. Notice that we have these $2. One is showing you the value of the dollar in 1981 and then in 2021. And here's the question. It says, how does the reduction of areas of the dollar bills compare to the reduction in their lengths? Second question, how could this cause a misrepresentation of the change of value? So remember this picture, so I'm going to slide my screen up so we can write. So let's talk about this. And actually, let me make a little bit of space here because I think I'm going to have more to write here. So I'm going to make some space. But we're looking at the different pictures, the different sizes. And if you think about it, first of all, the 2021 dollar bill shows about, it looks like it's about a third, and we can just guesstimate, as I call it, a 1/3 reduction in length to the 1981 bill. Let me come back over here. Okay, right? So going back up here real quick, it looks like it could be a third, maybe even a fourth, but about lengthwise, I'd say a third. Here's your halfway mark, right? And so right here's where this one matches up. That'd be about a third. So it shows about a third reduction in length, because the question was, what about the length? But here's the thing, the width. Let's talk about the width for a minute. But the width has also been reduced which, if you think about it, it's kind of exaggerating the change then. And basically, we just say in the value of the dollar. So going back to the picture, and I'll come back down in a minute. Yeah, the length was reduced by about a third. That's fine, right? Dollar to 1/3, but it also shrunk this picture. That's the width doesn't even match anymore. So basically what that does is that is basically exaggerating that change in the value of the dollar. Again, this is what we're talking about, misrepresentation of data. Let's look at example 2. Now, this is showing us the percentage of college students since 1910 who have been women. Both data, let's see if I can slide this up a little more for you. There we go. Both graphs show the same data. Yeah, they're showing you the exact same data. But let's look how the graph on the left kind of distorts that data. So let's look at these two data. Notice here, this is the same on both sides, right? Our x-axis is fine. 1910 to 2030, 1910 to 2030, evenly spaced out. Okay, we have no issues with the x-axis. But now let's look at the vertical axis, or our y-axis. Notice here, the axis, now here's something very important. The graph on the right starts at what? Starts at 0, which it should. If I'm here at the corner, right, that should be my 0 marker, and then we go up in even increments up to 100. This can kind of show us a more accurate representation of the data. But notice this graph. we're not starting at 0, we're starting at 30. And it's not going up to 100%. That is going to distort the data. Now let me kind of write out what I just said. So the graph, what we saw was that the graph on the left, and we'll say has a vertical axis, does not start at 0. Okay, that was one thing. Oh, and does not go up to 100%. Okay, that will distort the data. Thus, the more accurate one would be the one on the right because of our scale. Now, that being said, let's talk about misuses of statistics. I wanted to start off with a couple examples just so you can see what we're talking about when we talk about misrepresentation. And now let's look at misuses of statistics. Many individuals, businesses, and advertising firms misuse statistics to their own advantage. You should always examine statistical statements very carefully before accepting them as fact. In other words, ask yourself, 1, was the sample used to gather the statistical data unbiased and of sufficient size? Very important. If you are told, well, we did a poll and the poll said, 80% of people recommend this particular candy bar, and then you find out they only surveyed 10 people, could we really use that as a fact, as a poll? Probably not. We want to make sure that the statistical data is unbiased. Did you only survey a certain type of group of people? Or did you randomly survey people? You really want it to be random. And then number 2, is the statistical statement ambiguous? And what do we mean by that? Meaning it can be interpreted in more than one way. So let's keep going with some examples and we'll talk about each of these. Example 3. Here's a statement. 4 out of 5 dentists recommend sugarless gum for their patients who chew gum. Okay, this is something you might have seen in an advertisement. Well, let's go back to our questions. The first one was about who we survey. So we don't know how many dentists were asked. These are questions you would want to consider. We do not know how many dentists were surveyed. Like I said, it could have been 4 out of the 5 they decided to survey. We don't know that. So that is something that's important to ask. What is your sample size? Also, it could be that, here's something else to consider. We could also find that, let's say we did a larger survey and that 1 out of 100 dentists didn't even recommend chewing gum at all. Meaning, it's saying 4 out of 5 dentists recommend sugarless gum. But what if you did a large survey and it turns out that you have some dentists that don't even recommend gum at all, or you only surveyed like 6 dentists, and so that's really not, when I see things like this, claims from advertising companies, I would like to see where they got their data. And it's not always available. So I never take the word for it. Example 4, in a study of patients with cold symptoms, each patient was found to have improved symptoms after taking honey. Therefore, honey cures the common cold. Okay, well, what if the patients may have improved on their own without taking honey? Your cold virus will improve each day. So what if it was just a coincidence? What if the two were not even related? Meaning, let me just kind of say what I said in a condensed way. The patients may have improved on their own. Without taking honey. Let's say it that way. Meaning, if you had a control group, if you had two groups, one that took the honey and one that didn't take honey, you may have found that both sides, both study parts, did not need to take the honey because they improved. So in other words, they could have improved without even taking that. We don't know. That's the thing. Example 5. Morgan's is the largest department store in New York. So shop at Morgan's and save money. Well, let's say that is a fact, that Morgan's is the largest department store in New York. So let's say that's the fact. But does that necessarily equate to that you're going to save money if you shop at Morgan's? No. So just because Morgan's is the largest, right, store does not mean you will save money. It could be an expensive department store, and maybe you would save money at a different one. So again, a claim that is not really justified, a misuse of data. Let's go to number 6. 80% of all automobile accidents occur within 10 miles of the driver's home. Therefore, it is safer to take long trips. So we have a fact that's being made. That's fine. We're not arguing maybe that part. It's the conclusion that we really can't necessarily make just because of that. Here's the thing. Oops. Why is that a lot? And this is true. Most accidents do tend to occur, they find, within 10 miles of home. But that's because most driving is done close to home. People running errands, maybe their work isn't that far of a commute. Thus, one might expect more accidents closer to home. So it doesn't necessarily mean that they need to drive long trips. It just means that a lot of these accidents do happen because more driving is happening during that time. All right, one more. At Central High School, half the students are below average in mathematics. Therefore, the school should receive more federal aid to raise student scores. Here's something, maybe you didn't think about this yet, but did you know that half the students in a population are typically expected to be below average? Meaning this would be data from many schools. Therefore, you really can't argue that they should get more federal aid, because then that's going to have to go to most of the schools. So let me just kind of say that. Half the students in a population are expected to be below average. And what I mean by that is statistically speaking. Do we want that? No. But statistically, when they look at a large population, that tends to be overall what they see. And so that would not necessarily then be a good argument to receiving more federal aid. They would need to come up with more of a sustained and with more facts for their argument to get the aid. All right, well, that takes care of this section. This is just talking about misuses of data, misrepresentation of data, which happens probably more often than you realize. And I'm hoping this will help you be more aware when you're seeing advertisements about different products or different data and polls that are done, to question how many people were surveyed, who was surveyed. Very important questions. Okay, I'll see you for the next video.